Good morning everyone, I'm Yi Junming and I'm here today to present to you an interesting project. It's to make your own sodium chloride crystal. Before we get to the actual work, let's understand the theory behind the work. First, we need to know that what is sodium chloride? Sodium chloride is a chemical formed from one positive sodium ion and one negative chloride ion under the attraction force of electrostatic. And when we talk about sodium chloride crystal, we need to understand its structure and composition. To put it simply, sodium chloride has a face-centered cubic lattice, or we call it as FCC, meaning that there will be atoms at 8 corners of a given cube and also 6 atoms in total at each face of the cube. Just like the picture I have shown you. And if you look at the whole crystal macroscopically, each sodium ion will be surrounded by 6 chloride ions, and the reverse is also true. Since I have said that sodium chloride is a face-centered cubic structure, and it has a unique stacking arrangement like face FCC crystal. The layer of FCC consists of 3 layers. The base layer A consists of 7 atoms in total, 6 atoms surrounding a single atom. Second layer B and third layer C consists of 3 atoms forming a triangular shape, but both have opposite orientations. The 3 layers will have stacking arrangement in the order of ABC, ABC, and the layer of B and C will fill the gap left by the layer of A. Now you have understood sodium chloride, let's proceed to understand the theory behind the experimental procedure I will talk about later. So basically, to achieve the goal of generating a crystal, we have to produce a supersaturated sodium chloride solution. And to produce a supersaturated solution, we have to exploit the solubility difference due to temperature. Such that is that higher temperature would lead to the solution have a higher solubility. And as you can see, if we heat up the water and then add salt to produce a saturated solution, and when it cools down due to the solubility difference, we would get a supersaturated solution. And in the process of letting it cool down, some of the water would evaporate and further increasing the concentration. So because the water cannot retain that much of dissolved sodium chloride, and then the sodium chloride would end up start to nucleate and forming crystals. The key of producing a good crystal is to ensure the process of crystallization is slow and steady. So this is a brief view of all procedures of step to produce the sodium chloride crystal. I will explain it in the video later. So as you can see, I will first boil the water in the water heater. So I have poured the hot water into the cup already. And then next we will add salt into the water to produce a supersaturated solution. And then usually we need to add more salt than that, but this is just a demo. So you just add the salt until you see that the salt can no longer dissolve into the water, and it will be enough. And after that, pour the water into the container. Just a tiny layer enough to cover up the Tupperware should be enough already. So this is the salt crystal I have obtained after leaving the solution for a day, and then you can see most of them are cubic and some have very weird shape. We will discuss about the characteristic of the salt crystal in the slide afterwards. So that we have produced the sodium chloride crystal now, and we will start to question the result we have obtained. So the first question is why we use uniodized sodium chloride instead of an iodized one. The issue of iodized sodium chloride is that they contain iodine, and therefore in the supersaturated solution, the iodine ion will compete with chloride ion to attach to the surface of a growing crystal, and therefore disrupt the crystal growth. So the crystal form will have an irregular shape and is not similar to a cubic structure that an FCC cubic should have. And the second question is why the crystal form are square and cubic shape. Because the sodium chloride, as we have discussed, it is an FCC lattice, and therefore it should have a cubic shape. Obtaining a cubic crystal would mean that the result aligns with what we have discussed before. The third question is, The crystal produced have cracks diagonally. Why? The cracks are known as cleavage, and cleavage refers to the tendency of a crystal to break along a certain plane due to the weakness in its atomic or molecular structure. The crystal structure of sodium chloride have planes of weakness along certain directions, such as 100, 110, and 111 crystal plane. And the fourth question is, the crystal produced seems cloudy. Why? This is due to the imperfection during the crystal growth. During the process, there should be an impurity or air bubbles trapped inside the crystal, and therefore the crystal may become cloudy. The last question is, what does the ideal sodium chloride looks like, and is it possible to grow a larger crystal? The ideal sodium chloride can be seen from the image provided. The crystal should look transparent and have well-defined shape and edges. To grow ideal sodium chloride, it is important to provide it a stable environment to crystallize. So we have to place the solution in a place with cool temperature, moderate humidity, and with no air movement and vibration. So to grow a larger crystal, we need to use a small sodium chloride crystal and place it in the supersaturated solution to continue the crystallization process until it grows into a larger crystal. So this is the reference I have used for this video. Thank you.